The spire built at the top of the Burj Khalifa looks very small. Neither is the public allowed to go up there, nor are the floors within it heavily occupied. However, its importance in the Burj Khalifa is such that if it were not there, the stability of the entire building could be at risk. Constructing it was a necessity for the engineering team, and completing this task by any means was very important. Viewers, the spire of the Burj Khalifa is no less than a skyscraper in itself. The height of just this spire is greater than that of skyscrapers in more than half of the countries in the world. Made from 4,000 tons of steel, this 244-meter tall spire has a top antenna that alone weighs 350 tons. If this entire spire were to be removed, the height of the Burj Khalifa would decrease by 30%, leaving it at just 585 meters. This is the height where the last publicly accessible 154th floor is located. Above that, the spire begins, which ends at the tip of the Burj Khalifa. Floors from 155 to 163 are constructed here, but you might be surprised to know that these floors are not habitable at all because during strong winds the entire spire sways up to 6 feet. Yes, this is not a fault of the spire, rather its swaying is an advanced feature. Dubai's location is such that on one side is the Arabian Gulf and on the other is the Gulf of Oman. Strong sea winds are a part of Dubai's destiny, and at the height where the top of the Burj Khalifa is, the speed of strong wind gusts can easily reach up to 240 kilometers per hour. This spire absorbs the pressure of these winds. It sways up to 6 feet to keep the 154 floors below safe. American structural engineer William Baker was the first to design such a structure for the Burj Khalifa that doesn't block the winds but literally confuses them. When strong winds hit the structure, energy is generated, and this energy must be released somewhere. The 154 floors of the Burj Khalifa are connected to a main buttress core. If this energy were to be released into the main core, it could cause cracks in the concrete. For this reason, the spire is not connected to the buttress core. Instead, it is made of a steel structure. As you know, steel is a flexible metal. The energy generated by the winds is released into the spire's steel structure, which causes the top of the Burj Khalifa to sway. Engineers have designed it in such a way that it only moves 6. The spire not only serves as a sacrifice for the Burj Khalifa, but the device installed on the spire also protects the entire Dubai from dangerous lightning strikes. The device installed at the top of the world's tallest skyscraper is a lightning arrestor. It has a small sensor that detects active charges in the clouds around it. The lightning arrestor generates an opposite charge to attract the lightning toward itself. Then, through a steel wire, it safely channels the millions of volts of charge into the ground, protecting the entire building. Because this lightning arrestor installed on the spire is higher than the rest of the buildings, it not only protects the Burj Khalifa, but also the entire Dubai from millions of volts of current. So far, this lightning arrestor has perfectly performed its function 16 to 20 times. After each lightning strike, the small battery installed in it needs to be changed, which requires going to the top. As you know, Dubai has been subjected to sandstorms and strong winds with speeds reaching up to 100 kilometers per hour at ground level. Such strong winds pose a significant problem for tall skyscrapers. Near New York City in Midtown Manhattan, there is the Citigroup Center, which is only 279 meters tall. After its construction in 1978, a major engineering flaw was discovered in its design. An engineering student from Princeton University noticed that the Citigroup Center would not be able to withstand the load of strong winds. Only 25% of strong winds could easily topple the Citigroup Center. When this flaw reached the building's designer, they immediately did some calculations and agreed with the engineering student. It is said that this matter was kept secret, and additional dampers were added under the guise of maintenance, and this information was not disclosed for many years. When strong winds hit a building, rotors, also known as vortexes, are created on the back of the building. These vortexes are pockets of low air pressure that cause the building to move sideways. Once the building starts to move even slightly, these vortexes greatly amplify this movement. The most perfect example of this is a swing in a park that you have probably all seen, swung on at some point or another. When swinging, if you move your legs in sync with the swing's movement, the swing naturally speeds up. This is because we are moving our legs in resonance with the swing's frequency. This phenomenon is called resonance. In the case of the world's tallest building, Burj Khalifa, structural engineer William Baker designed it in such a way that it manages the winds.